Hi, welcome to my channel IAL Chemistry class. This is Shaka. Today I'm going to discuss this paper, Major 2022, Unit 1, WCH11, which is the first paper in the entire examination. Please subscribe my channel if you like to see this kind of videos more to encourage me to do more and more clear videos of this nature. We move on to the video, the first question, which goes as the elements in their most stable elements with their most stable state exist as the question number one asking. So obviously the answer is the D because element can exist as like neon atoms or molecules like nitrogen, oxygen, or the giant structures such as carbon. Moving on to the second question, which is based on this, the calculation about this, the nitrogen gas. It provides the nitrogen gas which contain 1. Second question, it gives you the information regarding the nitrogen. It contains 1.20 times 10 to the power 22 molecules. Find the mass of this. So your question is to find the mass of nitrogen. What you know here, the nitrogen is, it is this 28 gram equals to 6.02 into 10 to the power 23 molecules. If you get this much of grams, one molecule, it gives you 28 divided by 6.02 into 10 to the power 23 in grams. Question based on 1.204 times 10 to the power 22, it comes as 28 divided by 6.02. I take that 23 has become minus 23 times 1.204 times 10 to the power plus 22. Answer comes in grams. Or if you simplify, it become 0.56 in grams, which is the answer is C. We move on to Moving on to the third question, they give you the equation magnesium and sulfuric acid producing magnesium sulfate and the hydrogen gas. Asking you to find the ionic equation and it gives you the state symbols. It is added the MgO, which is a solid, and to the aqueous sulfuric acid, aqueous and the gaseous hydrogen are produced. So the ionic equation, we are unable to split the solid MgO, but can split the H plus and SO4 2 minus ions which generate Mg2 plus ions and the SO4 2 minus together with H2 gas. By looking at the equation, it is easier to identify sulfate is the spectate ion, can be cancelled off in the equation. So ionic equation become MgO solid react with 2H plus gives you Mg2 plus as well as the hydrogen gas, which gives you the answer. Best answer is the B. Moving on to the fourth. Moving on to the question number 4, it is asking about the sodium chloride which has been produced a solution in 250 centimeter cube solution by dissolving 10 grams of sodium chloride. Your question is to find the concentration of sodium chloride solution. So it is to be found the number of moles. If you get 28.5 grams of NaCl is 1 mole. If you get 1 gram, it is 58.5. 1 divided by that. Therefore, 10 gram gives you this much moles of sodium chloride, which is in 250. Therefore, in 1000. Once you multiply by 1000 for the fixed volume, it comes as the concentration. So, it is the answer is 0.684 moles per decimeter cube, which comes the question number 4. The best answer is the answer B. Moving on to the question number 5, it is asking about this certain compounds of chromium. It is prepared 10 centimeter cube of test tubes, which is 10 centimeter cube, each one with 1 centimeter cube of chromium contained substance. So we don't know what is the chromium species, but it is contain the chromium N plus about the substances. It's added to each of these solutions excess of silver nitrate of 0.1 mole per decimeter cube of silver nitrate. So this silver nitrate being added until there is a precipitation occurs. So it is that silver ion combined with the chloride ions to give silver chloride white precipitate to be produced. In the graph being provided to you, the precipitate produced versus the amount of the volume in silver nitrate added. Your question is to find the formula of this chromium chloride. So you can see this the graph which gives you exactly volume being given to you into your x-axis, which is this volume of silver nitrate added in centimeter cube. You can see clearly the graph being started from this zero goes a steady increase and then goes straight line graph after adding 3 centimeter cube of this silver nitrate. So it is that rare ratio of this chromium contains species and it is we have no idea, so I just put the chromium N plus and the silver nitrate because it is reacted with 3 times with one of the complex. 1 to 3 is the ratio, so obvious 1 chromium should contain 3 chlorines. So the answer has to be the best answer is the D for the question number 5. Moving on to the question number 6 about the question based on the scandium, and it is this scandium being provided the atomic number 21, mass number 45 in this question number, where it is our next question based on the question number 6. Scandium provided 21 and the 45, the mass number. Your question is number of electrons in an atom of scandium 1 plus. Obviously, the number of electrons should be 21 when it is neutral. When it is lost 1 electron, it should be the number of electrons 20. 6A part, the best answer is the A. 6B part, the mass spectrometer. It's asking about the mass spectrometer based on the scandium compounds because it exists in scandium 1 plus as well as the scandium 2 plus ions. Scandium 1 plus, scandium 2 plus, both of that the mass number is 45. Your question is what's the value of the mass over charge ratio mass spectrum with scandium with 2 positive charge? Mass over charge should be 45 divided by the charges to answer should be 22.5. So the best answer should be it is 22.5. The answer is A. Moving on to the question number 7, the question asking about the first ionization energy of iodine. So it is your part is write down the question and then compare your answer because iodine gaseous to be converted in one positive iodine by losing one electron. So the seventh question, the best answer is the D. Moving on to the question number 8, which is asking the electronic configuration of nitrogen. When you ask regarding the electronic configuration of an element, it is the best part is that you should write down the electronic configuration. 1 is 2, 2 is 2, and the 2p4. So it is 7th, it is given to you, therefore it has to be 1 is 2, 2 is 2, and the 2p3, which gives in this box it is completed in the 1 is 2 and the box is completed for 2 is 2. 2p3 is each electron is now phase present in one orbital giving this the organized state, which gives you the best answer is the C. Question number 8, the best answer is the C, and the question number 9 regarding the manganese. We are moving on to the question number 9 that is based on the manganese electronic configuration, but it is asking about manganese. The atomic number is 25 and the mass is 55. There are 25 electrons. How many numbers of sp and the d electrons in an atom of manganese? Best thing is write down the electronic structure in the second orbital. third orbital 3s2, 3p6 and 3d5 and the 4s2. In this electronic configuration, you can easily identify s electrons should be obviously 2, 4, 6 and 8. So the s electrons are 8 and the p electrons are 6 here, as well as another 6, 12. D electrons are 5. So the best answer which gives these values is the 8th question. Ninth question. Ninth question, the answer is the B. Moving on to the question number 10, it is regarding about this the lithium iodide structure. Lithium iodide is 9 compounds, so obviously lithium iodide contain electrostatic forces of attractions between lithium ions as well as I minus opposite charges are present. Yes. Second one, the repulsive forces between similar charges like charges is yes, and some covalent bonding also yes, because it is the bigger anion and the tiny cation, so there would be polarization or distortion. Now, negatively charged and minus signs occur, so the 10th one, the best answer is the D. Moving on to the question number 11, which is based on certain properties of 5 substances. So in the 11th question, there would be that 2 parts they are based on their behavior and the electrical conductivity. 11th question, A and the B. First part, the 11th, A, it's asking which could be metals. Obviously, the metals are M and the N, because you can see M and N do conduct while solid as well as liquid. So the best answer is the C. And the B part is this which substance has properties showing it changes from molecular structure to ions. Obviously, it is non-conductor in the solid and the liquid, but it conducts in solution. So the best answer is the Q. Q comes, the answer is D for question number 11. Moving on to the question number 12, it is asking this structure, which is the dimer of aluminium chloride, because 180 aluminium chloride exists as a dimer of Al2Cl6. To get the structure of, they say, L2Cl3, there should be 2 aluminium can be connected with 3 in this condition with 2 dative covalent bonds. So it is this 2 aluminium chloride molecules, they connect with each other through 2 dative covalent bonds. So it is donating electron pair here as well as here. 2 dative bonds are present, so the 12th best answer is the same. Moving on to the question number 13, it is based on, it's the carrying out chemical experiment. So it is you're asking, we should consider about the 2 properties, inherited property of this substance we call, it is the hazard. Question number 13, hazard is always fixed and the only answer gives the hazard is fixed, and this is the risk also fixed is wrong. Risk is vary how we do handle the substance. So the best answer for 13 is the A. Question number 14, we are moving heterolytic bond fission. Heterolytic bond fission means the unequal bond breaking, may be example hydrogen chloride, or it is in the aqueous solution hydrochloric acid, unequal bond breaking. Result would be oppositely charged ions. Hydrogen lost its one electron, chloride ion having extra 1 electron. So the best answer is the D for question number 14. Moving on to the question number 15, you can see it gives you the 4 structures for a hydrocarbon X. So it is the hydrocarbon X gives you the 4 structures. You are asking which is studied with the MR value weighs the 98 grams per mole. At the same time, it does not decolorize bromine water. So the C answer obviously wrong, and your choices should be A, B as well as D. So if you look at the A and the B and the D, you can see the structures given to you. It is based on extra carbon present in the B, so I'm not drawing the B structure. It is somewhat lengthier than A. At the same time, it is this answer comes for A would be, it is the structure as well as it is gives you this kind of structure. But in the B structure is it's the same as that and it is having this kind of thing. So the B is out. You can see the number of carbon. It is having 1, 2, 3, 4, 5, 6, 7 carbon. 1, 2, 3, 4, 5, 6, 7, 8 carbon. Because of that the B is out. But in the D structure this gives you this kind of the explanatory part is given to you like this and it's asking which is 30 with this not showing A or D. Now your choices are 7 carbon each is present. Now this is 8. So 1, 2, 3, 4, 5, 6, 7 has to be present in both of them. 98 means it should be based on either C7, H14 and 16 or C7, H14. C7, H14, if you find the molar mass, it comes, it is 12 times 7 plus 14. 84 plus 14, 98 comes. And this goes the answer 96. Therefore, A is not correct. Best answer is the D, which goes as this, exactly the same as the molar mass. Moving on to the question number 16. The 16 based on the explanation asked about the atmospheric pollutants. Question number 16 regarding the atmospheric pollutants. So it's the pollutants are not emitted during the combustion of alkane fuels. So nothing to worry about question number 16. Obviously the answer is say ammonia never produced during the combustion product, but nitrogen dioxide, sulfur dioxide and octane unburned hydrocarbon which has also get a chance to get released. 17th question based on this day occurs in the propagation step in the reaction methane and the chlorine. So you should identify what's the propagation step is. Propagation step means it should use one free radical and again it is generating another free radical. Obviously A answer is not correct and it is the answer which is based on this the D also not correct and it recreates like the hydrogen free radical. So the best answer is CH3 free radical and it can attack the chlorine molecule. This happens during the free radical substitution of the alkanes. So the best answer which gives you the 17th is the B because it uses one free radical producing another free radical. So it is that chloromethane is would be the product during this reaction. Question number 18, which is the last MCQ question in this paper, is based on the IUPAC name the compound of the structure given to you. It gives you this, the question number 19, there is a double bond as well as it is the CH3 groups, two CH3 groups on either side and the chlorine atom as well as the hydrogen atom. What could be the IUPAC name? So it is easy to recognize. It should be that EZ isomerism, not the cis trans, because different groups are present. So you can identify CH3 present, but again hydrogen and the chlorine are present. So it is obviously EZ isomerism. We are looking for atomic number of the atom directly attached here, the CH3. 6 is the one here. This carbon the highest priority, this carbon the highest priority should be E isomer. So obviously the answer is C because that only E isomer is given to you. This is the C answer because it is the 2 chlorobutane. You can start 1, 2, 3, 4 carbon. Butane as second and third the double bond and second carbon has a chlorine and it's the E isomer. We came to the end of this section A with this part. Moving on to the question number, I think this is the question number 18. I made a mistake here. This is 18. Moving on to the question number 19. We can move on to the 19th question, which is starting from the section B now. Section B would be starting the element iron forms two chlorides. Question number 19, it is the element iron, it is the metallic iron. So it exists as a two forms, two chloride, iron 2 chloride and the iron 3 chloride. So it is a part of the question is starting with the iron and it is allowed to react with hot solution of iron 3 chloride and it is added into iron 3 chloride solution. FeCl3 solution. It is having the volume 200 and the concentration zero point 0.5 mole per decimeter cube. Zero point 0.5 moles per decimeter cube, 200 centimeter cube. Some iron has been added. Then in this solution is produced the reaction complete all the iron because iron and iron trichloride everything turning to iron in 92 plus at the end. Initial mass the iron powder used was 6.17 grams. So it is the iron mass of iron initial is provided to 6.17 grams. It has been provided at the beginning, it was said that the iron mass, the iron initially 6.17 gram. At the end of the reaction, it is been remaining 3.38 grams. So you're asking to find the AFS1 number of moles of iron that react. Obviously, you have to see what is the mass of iron react would be 6.17 minus 3.38, which comes as 2.79 grams. 2.79 gram of iron being reacted. Therefore, what we know about the iron is if we say 55.8 grams of iron equals to 1 mole. And if you get just 1 gram is 1 divided by 55.8. Now 2.79 gram being reacted. Therefore, 2.79, the answer comes as this, the number of mole would be equals 2.05 mole. Having known this answer, 0.05 moles of iron being added into this one, on simplification, it's the 0.05 moles of iron being added. So after doing this experiment, it is added into 200 of this the zero point 0.5 mole per decimeter cube by chlorides. You are asking in the second part, find this is the A first one to find the number of moles of iron. Second part to ask this number of moles of the iron chloride. If you get 1000 centimeter cube, it is having this is iron chloride would be zero point 0.5 moles present because zero point 0.5 mole per decimeter cube, 1 centimeter cube, zero point 0.5 divided by 1000. Now it is in 200 centimeter cube. This times 200. Once on simplification, you are dividing that, so it becomes zero point 0.1 moles of iron being added. Iron 3 chloride solution here is zero point 0.1 mole. Now it's very clear 0.05 mole of iron is added to zero point 0.1 mole of iron chloride. Use your answer for this to your third part. It's asking to find it is the ionic equation, the reaction of iron with iron chloride. You should mention with the state symbols. So it is iron react with iron tray, and at the beginning it says the instructions, finally everything converting to iron 2 plus. Iron reacted was 0.05 and the iron 3 plus 0.1. You divide both with the smallest number. Once it is divided with smallest numbers, you get this reacting ratio is 1 to 2. So 1 iron react with 2 iron 3 plus, that's the reaction would be. Then the finally all 3 ions would be in iron 2 plus, so it should be the ionic equation and the state symbols can be added. This is that A plus with solid ion with a cosine 2 chloride, which gives you altogether 3 marks to the A3 part. Moving on to the B part of the question number 19, B part, it says about this information being provided. Now you to find this water of crystallization present in this hydrated iron 2 chloride. Concentration in the B part in the same question, it is now increased by heating gently to remove some of the water. Solution is allowed to cool and the pale green crystals are being produced. Iron 2 chloride aqueous solution converted into iron 2 chloride with certain X amount of the water. At the end it produces the solid, and it produces in this solid, and it analysis shows this solid contain 21.8%, 28.1% of this entire compound contain iron. So the iron, this is the percentage of iron in this compound being identified through analysis. It is 28.1 percentage of iron. Question is asking to find the value of x. So to the entire MR of the compound contain 55.8 gram into 100 equals to 28.1 can be simplified and find the value of MR. It comes 199. Once you get the 199 for the entire the molar mass of this one, now it's much easier because it is gives you the further step here. FeCl2 plus 18X is equals to 199. Therefore, 18X equals to 199 minus the molar mass of this would be 55.8, and that 71.8 is the mass of FeCl2. Therefore, X can be simplified from that, and it could be equals to 4. Therefore, X is equals to 4 in the sense it gives you FeCl2 is attached with 6 of water molecules. So, this X value equals to exactly 4. So, this is dot 4H2O, which is the solid iron 2 chloride crystallized from this aqueous solution. We came to the end of question number 19, and we are moving on to the question number 20. This is based on the isotopes. Moving on to question number 28, says about the naturally occurring bromine. It exists as two isotopes of 79 and the 81. Your question is state what's meant by the term isotope, which is the A part, gives you just 1 mark. Just isotopes means the element, it's the atoms of the same element exist with same number of protons but with different number of neutrons, or same you can refer to the same atomic number but with different mass number, because it is just 1 mark. Complete the table. You're asking the proton, electron, neutrons, protons and the electrons and the neutrons for each one. Both of this would be the 35 would be the atomic number. So it should be protons 35 for both of them. Neutrons would be equals to for bromine 79 is the 44. Number of neutrons vary, but the protons and the electrons are same for both of that gives you 2 marks. And the C part you're asking to draw the dots and cross diagram for bromine molecule. It's much easier, the very simple molecule where it is that 7 electrons present in that each bromine atom. They do share with this one electron. Apart from that, one shared another 6 more electrons here, or 6 more electrons with the other bromine atoms. There is a shared pair of electrons, so it changes into dot and first diagram would give you 2 marks. And the second part of the question, it is the C second part. This is the C first one, and the C second one asking describe the formation of molecular ion of bromine in the mass spectrometer, include an equation. C second one, the mass spectroscopic This is the ones where the ionization occurs, so that fast moving electron with high energy collide with the bromine molecules, leaving an electron. At the same time, it generates another electron has been left over. This equations you can write down the gaseous as well as gaseous molecular ions are generated for 2 marks. Third part is the mass spectrum grid draw the peaks of bromine molecular ions. So this part would be the C third one. So it's the C third one. It is provided you kind of a grid here, and you are supposed to go draw how does this starting from 158, 160 and 162. It is that you are given the values 158, 160 and 162 because bromine can combine with this 79 as well as with another 79 with the molecule which is having 1 over 2 times 1 over 2 would be 1 over 4 times because each one has 50% would be that existing in a sample. It said at the beginning two isotopes. What is meant by then it is asking these isotopes are there in the definition. Alright, so this one pairs the bromine molecule showing isotopes in the sample has the same relative abundance. If it is same means they both exist in the same amount in a sample. Another bromine can exist with that with the 7981 with one positive or else it could be the bromine 81 and the 79 in the molecule or else it could be the bromine and the bromine 81 with the 81 in a sample. So it's very clear 1 over 2 into 1 over 2 become 1 over 4 for here again 1 over 2, 1 over 2 and the 1 over 2. For this 4 it is 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2 because there are two different combinations so it should be equals to this is 1 over 2 here become 1 over 4. Now it become 1 over 4 plus another 1 over 4 become 1 over 2. And this combination again 1 over 2 times 1 over 2 become 1 over 4 is the combination. So there are bromine molecules would be having 79, 79 with 1 plus has a chance of producing 1 over 4% would be the bromine molecule. The other one with the bromine and the bromine which is 79, 81 with the combination 1 over 2 times 1 over 2. So there would be the opportunity for these ones to be exist. Everything has to be multiplied by 2. So you can see now it is 2 divided. We can multiply by 4. Everything can be multiplied by 4. Then it would be the answer 1 to 2 to 1 ratio. So this 2 would be existing as it is that 1 over 4. This is that 1 over 2 and again 1 over 4. So it is that the bromine and the bromine 79, 79 which is at 158 1 over 4 times exists. Also the bromine. So this ratio we can multiply everything by 4. So it should be equals to 1 to 2 to 1 ratio. 150 to 162, 162. There should be peaks at this area. If it is 1 time, 160 should be the 2 times. So that finally it is that your y-axis the relative abundance and the x-axis would be equals to the mass over charge. This x-axis is the mass over charge and the relative abundance you are getting these three peaks are in 1 to 2 to 1 ratio on the grid, that gives you 2 marks. So moving on to this, the D part, the question you're asking to find the mass of relative molecular mass of the sample of bromine. Relative molecular mass of a sample of bromine, that asked in your D part, but you are provided some more further information. Right, it is the D part where they explain you to give this the bromine 79 in a sample as well as bromine 81 in a sample, and their percentage abundance being provided to you as 56.38 and the 43.62. These are the percentages of these two isotopes. Calculate relative molecular mass for bromine molecule. So to get the bromine molecule relative molecular mass, you should know what is the atomic mass of bromine. These two added together, it comes 100. Out of 100, 56.38 times 79 plus out of 100, 43.62 times 81. Once you simplify, you get this atomic mass is 79.87. This is the atomic mass of bromine. In order to get the molecular mass, so it has to be once identified 79.87, another 79.87, so the molecular mass has to be 79.87 to be multiplied by 2. It gives you the answer 159.74 is the relative molecular mass of the bromine, which gives you 3 marks for your working. We came to the end of entire question number 20. We are now moving on to question number 21. Question number 21, it is starting about the elements of carbon silicon, both form dioxide. Carbon dioxide is a simple molecular covalent structure. Silicon dioxide has a giant structure. This information provided at the very beginning. Question is that the first one is describe the covalent bond between a silicon atom and oxygen atom. Silicon atom and the oxygen atom in silicon dioxide, in terms of the particles involved, it gives you 2 marks. So there should be the strong electrostatic forces of attractions between a shared pair of electrons and two nuclei. So the silicon is a bigger one and the oxygen is a smaller one. And the oxygen silicon, there is a shared pair of electron, strong electrostatic forces of attraction between two nuclei and a shared pair of electrons. It is the answer to the point. They are expecting your answer in terms of particles involved. So it gives you 2 marks to mention this shared pair and the two nuclei of two atoms are the particles involved. And the second part, compare and contrast the covalent bonding of carbon dioxide. So it is the A second one, carbon dioxide, as well as it is that silicon dioxide in terms of orbital overlap. So you are referring to your answer with that in terms of orbital overlap. You can see it is that obviously double bond is present in the carbon dioxide, which is a sigma and the phi bond. And for silicon dioxide, the one covalent bond has only single bond. So when it says the similarities, the differences, compare and the contrast, you should write down what are the similarities. So the similarities as well as you should identify differences. In both of these, the similarities, they both contain the sigma bond formed by overlapping p orbitals in end-on overlap ways. We call it as that end-on overlap here. That's the similarity. End-on overlap of the orbitals of p orbitals creating sigma bonds are present in both of them is that similarity. And it gives you just 3 marks, and the differences should be there would be this the a sideways overlap between it is the two p orbitals in carbon dioxide, which creates phi orbital between carbon and the oxygen. Sideways overlap creates spice covalent bond in the carbon dioxide, which is not present in silicon and the oxygen bond. I hope this is clear about the similarities, the differences in terms of the orbital overlap, where there is this end-on overlap with sigma bonds are present in both, so it's a similarity. Differences would be the sideways overlap of p orbitals in only in carbon dioxide, which is a phi covalent bond. Moving on to the B part of the question. 21 question B. First one is the shape of the carbon dioxide molecule affects its physical properties. First part in the question asking to explain the shape of carbon dioxide molecule, and it gives you 3 marks. The shape of the carbon dioxide linear shape with 180 bond angle. This is not necessary as it is not asked. Because why this gain the shape with the linear shape? Because it is that in concerning the shape, we speak about the double bond also same as a single bond. There are two bond pairs of electrons. There are two bond pairs of electrons, no lone pairs of electrons on the carbon atom, which is the central atom. Two bond pairs, they arrange with minimum repulsion and maximum separation. So it should be minimum repulsion and maximum separation. It gain a shape of linear. So you get the 3 points for no lone pairs and only two bond pairs around carbon. They arrange with minimum repulsion and maximum separation, 2 marks, and the linear shape, 3rd mark. Explain the polarity of the carbon oxygen bond, which is the second part of the B it's asking. The second one, it's a 2 marks again. Explain the polarity. Yes, oxygen bow electron negative. They are referring to carbon oxygen, and it gain tiny positive charge, and the other oxygen gain tiny negative charge. So it is there is a charge separation, slightly positive on carbon. Oxygen becomes slightly negative because oxygen is more electronegative. That's a 2 marks. And the state whether or not you're asking just to state. It is the carbon dioxide is polar or non-polar. It is state it's non-polar. Justify your answer because it is a symmetrical molecule. C part of the question 21, we are moving to this silicon dioxide structure is given, which is similar to the diamond structure. Your C first part of the question asking. Use your knowledge of structure of diamond suggest how the structure of silicon dioxide SiO2 is similar. Similar to that of diamond, yes, just 1 mark. They both are giant structures. It is the giant structures, 1 mark. You are asking the similar to the structure similar is both of them are giant structures. Second one, just 1 mark. Give a possible reason why SiO has a lower boil melting point than it is present in this the diamond structure. Diamond is only with the carbon to carbon covalent bond. Silicon oxygen, there will be two different atoms, but they both these atoms are bigger than the carbon atoms. So your question, there are less bonds per atom in while SiO2 because that it is two bonds per molecule. It is there. It is the this is producing more bonds. Carbon is smaller, produce more bonds than the silicon and the oxygen because it is that they form two bonds per molecule SiO2, but there are lots of bonds are present in the same fixed volume in diamond structure. Moving on to the question number 22, it is they given the organic compound we call the cinchoberine. Question number 22, it gives you this cinchoberine structure. This is you call this the compound gives the ginger its characteristic flavor. IUPAC name of the structure given to you. You are asking to draw in that structure. So you are given this part of the structure is that cyclic structure where there is a double bond and there is a methyl group is present, and it gives you this kind of continuation, and it is starting here. Deduce the molecular formula of this gingerbread. If you get this entire 15 carbons are present, C15, C15 alkane has to be C15 H32 and another 2H34. But here if you count this structure, it is to be 1, 2, 3, 4, 5, 6 carbons. So it is 1, 2, 3, 4, 5, 6. Six carbon atoms are present where there is a double bond is present here, and apart from that there are two double bonds and the two methyl groups. Altogether 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 15 is the easy way is 15 times if it is an alkane we have to get 32. 2n plus 2 is the 32. Because of the ring structure, we should give away 2 electrons and 3 double bonds, 3 carbon carbon double bond, another 3 electrons it has to be. It is we are taking 2 per double bond, 2, 4 and the 6 electrons are removed. When 8 electrons are removed from 32, it will be equals to, it's the structure comes now with the formula C15, H would be 24. So it's easy way of calculating the value rather than it is just counting one by one. Your part is when zingiberine reacts with excess hydrogen bromide, your question is next would be there are a number of possible products. It's a one gives you the major products. You ask in the type and the mechanism is that addition because no more double bonds in the final product has been taken place through electrophilic addition mechanism. And it is the second part which is your answer is that the C second one of this question based on it is asking that complete the mechanism for the reaction of zingiberine with 1 mole of hydrogen bromide. It gives you a simplified version of this one, which gives you that the double bond is present and this is been attracted and the rest of the molecule has been placed as A. How does the hydrogen bromide being added across to this one was asking. So hydrogen bromide is approaching. This mechanism gives this entirely 4 marks, so you can see that the curly arrows are there. So it is the double bonded electrons moving towards the two curly arrows. So it would be producing this, the double bond open up and it gives you, this is the structure where it is the one bond goes to the A and hydrogen goes into one of this structure and it is there we can't see here it is the basically it is that you are asking to give you the one molecule of hydrogen bromide and you are asking to give you this one supposing if the hydrogen is attached here then it has to be bromide should comes over there then there should be then it's a bromide ion with an electron pair should move over there. So to give this final product would be that bromine is attached to this is that 1, 2 and the 3 and the A here. Bromine should be attached to this part is I have drawn this the major product in this one. So this that and the second part the reaction of C there are two possible products are given two possible products, one which has been drawn already, or it could be swapped into the other part where it comes as the A. Bromine could be now present in the middle carbon, either here or the bromine here and the hydrogen here. So it has been mentioned one and the two structures in this one. It is the third part of the question. Explain why it marked as one and the two. So that one and the two, why it is marked with the one and the two, why one is a major product. So the one being marked like that, it is just one as the bromine here, and it is this part is the A, which is the number one compound, or else it can be marked like this with the A where the bromine comes to the middle. So it is labeled as the 1 and the 2 here, which is your third part of the question. Why 1 is the major product? By referring to the mechanism, because this has been produced through carbocation intermediate, which was having we call tertiary carbocation intermediate, which is more stable. This has been produced through, it is the secondary carbocation intermediate. So the reason why it's a major product is it is produced through tertiary carbocation intermediate, one produced which is more stable than secondary carbocation intermediate. And the D part of the question, since superane react with hydrogen in the presence of the catalyst, you're asking what's the name of the catalyst is. Name of the catalyst is a nickel in the presence of hydrogen only. Hydrogenation occurs, so is a nickel the catalyst. And the D second part, there would be a question asking to use the ideal gas equation. PV is equals to nRT. Two moles of zingiberine react completely with the hydrogen. We are provided the temperature and the pressure. Temperature is 150 to be added. 273 is the Kelvin. Pressure is provided to 120 kilopascal. 120 times 1000 pascal would be the pressure. So the temperature, once you added these two values, it equals to 423 Kelvin. Under these conditions, it is that we are asking to find the minimum volume of hydrogen. You are asking the R is the gas constant, 8.31 joules per mole per Kelvin. Once you get this part of the question, your next part would be asking you to. It's advisable to keep all the figures of known figures in this part where you can directly apply to PV equals to nRT and the number of moles. 2 moles of zingiberine. So 1 mole of zingiberine need 3 moles of hydrogen as 3 double bond. N should be the 6 because the 2 moles of zingiberine need 6 moles of hydrogen. You are asking the volume. nRT, and you have to take V out of the expression. nRT divided by P. So it is 6 times 8.31 times 423 divided by the pressure is 120 times 10 to the power 3. Volume comes as the answer in the meter cube. Question is asking to find the volume of hydrogen. It's not mentioned regarding this. What's the volume is. So you can simplify come 0.1757 1757 in meter cube. As it is not asked regarding the units, you can leave it as this the meter cube the answer. We came to end of question number 22. Moving on to the question number 23, which is the last question in this paper. It is based on this question number 23. It is asking about the organic waste. Waste is also kind of a major thing as the scientists are facing, because to get rid of the waste, it is a major issue. So try a lot to reduce the waste generation during industrial reactions. Question number 23. Organic waste may be disposed by landfill or incineration. Both processes produce gases. So it produces you now this the table with the gas and the percentage by volume. The main gases produced. These are in the typical landfill sites are given. You're asking in the first part of the question based on that asking the process where these gases produce is the decomposition for 1 mark. Second part is state the main environmental problem caused by landfill gases, identifying the gas or gases. Obviously, the carbon dioxide and methane both are responsible for global warming because they both are greenhouse gases. They are responsible for global warming. And the third part of third part, it's asking now 1 ton of landfill waste produces approximately certain amount of this is 12.5. A third one of the question number 23, 1 ton of landfill waste. It is that a third part is a calculation. You're asking the mass of carbon dioxide produced in a year. Carbon dioxide mass produced within 1 year. So that the data provided you 1 ton landfill gases are generated per day from the 1 ton of the landfill waste. 1 ton of the waste generates. This much of the waste generates 12.5 decimeter cube of this landfill gases per day. You're asking to calculate the mass of carbon dioxide produced in an year for a typical landfill site. So it is which contain 90,000 tons. 90,000 tons of waste is presented in this particular waste site, and it is that site which contain this much. Alright, so it is the 1 ton produced 12.5, therefore 90,000 tons. So 1 ton produced 12.5 decimeter cube landfill waste gases, therefore 90,000 tons. Obviously, 12.5 times 90,000 would be the decimeter cube of waste is generated, which will simplify come 1.125. 1.125 times 10 to the power. I hope you get these digits clearly. 10 to the power 6 decimeter cube. So 1.125 10 to the power 6 decimeter cube. This is per day produced by 90,000 tons. So it is the carbon dioxide generated is that 45% if you go through, because this much of decimeter cube is not only carbon dioxide, it's methane, nitrogen and sulfur compounds as well. From that amount it is produced carbon dioxide. So it is the carbon dioxide percentage by volume. So the volume of carbon dioxide per day is from that 1.125 times 10 to the power 6, and from that 45% decimeter cube. On simplification, you can get the answer 50,500 and it is 5.06 and it is 250. So this digit should be much more carefully handled. This much of decimeter cube of carbon dioxide produced from this entire landfill site per day, with it is compared with 45% of the carbon dioxide generated. So when you are referring to decimeter cube, your next part would be asking the mass of carbon dioxide. So that means if you get 1 mole of carbon dioxide occupies 24 decimeter cube. 24 decimeter cube of carbon dioxide has a mass of 44 grams. So 1 decimeter cube has a mass of 44 divided by 24 grams. So that is 1. We should find this much. Our answer we calculated, it is that the 506 and 250 decimeter cube. From that the mass comes this 44 divided by 24 times 5.0 and the 250 answer comes in grams. As you simplify, it should be that is per day. This is within 1 day. This is being produced. Therefore, per year we can get 365 days. So our answer can be again 44 divided by 24 times 506,250 multiplied by 365 in grams. Once you sort it out everything, it comes a big answer 3.39. So the final answer for these 3 marks would be you to multiply that by 365 as the question asks per year amount of the mass in carbon dioxide generates 3.39 times 10 to the power 8 grams produced within 1 year. It's a huge quantity, that is why it's trying its best to reduce the waste when it's in industrial reactions, as well as it is from this that waste generated by using this the polythene or polymer products. B part of that question gives you about two advantages of incineration over landfill. So it is the B part of the question. It gives you the information regarding that why the incineration is now regarded as better and the two advantages of incineration over usual and the common way of the landfilling. So once it's asked about the advantages, you can refer to it is kind of this the pollutants can be trapped easily in the incineration. But in the landfill, pollutants are just releasing to the atmosphere. So it is that no land is just wasted, lands are saved, land can be saved to do other agriculture production processes. Incineration saves the land, of course, yes, because the landfilling takes a lot of land. So you can mention those advantages. Also, that the pollutants can be trapped easily is a major advantage, as well as the land is saved is a very good advantage. Also, it can be mentioned that it is that less space is needed, which can be used for kind of the generating food for. This is that kind of the growing food crops can be used that land which is saved. C part of the question it says the environmental groups prefer recycling to both landfill and the incineration. So that question number 23 C part just with 1 mark you asking one advantage of recycling. Recycling preserves the natural resources. Also less energy is used. We came to the end of this paper discussion. I hope you understood, and it is that it would be encouraging to me if you subscribe my channel and if you can press the bell icon as well. Hope to meet up you soon with another video. Thank you so much for watching.